Thank you guys for coming out. This is the session entitled Data Must Flow, an Analyst-First Perspective on the Future of SOC. Before I try to describe what exactly that means, just a little bit about myself. I got my career started at Mandiant many years ago, where I spent about 8 years doing both incident response and red team engagements. I led a threat hunting research team at Microsoft for about 2 years, and now I'm part of the incident response team at LinkedIn. All of this together, one of the things that I've sort of vibed with the most is the life and sort of trials and tribulations of being a security analyst and an investigator. So it's most of what I did, and honestly, the investigator mind frame is what informed a lot of my offensive work as well. So my focus for the last several years has been, how can I get my security analysts, or security analysts in general, not even just mine, to do better work faster and with less pain? Because it is painful. I mean, anyone who's ever tried to merge timelines in Excel knows how painful the process can be to do it right. So, many more years ago, 1965, a very wise man predicted the future of where we were going with this whole AI thing. First, humanity would create thinking machines. You probably heard all about this on Twitter. Of course, you know, AGI is always just around the corner. Next, these thinking machines will destroy humanity. This is another hot topic in media. Now, he said that we would all band together and we would destroy and sort of rein in these artificial general intelligent machines that were threatening the existence of humanity. And after we did, we ban it. No more artificial intelligence allowed. Instead, we would integrate this technology into biological organisms, humans, so that we have computing organisms, right? Human beings who can think and perform like machines at the same scale, rate, and speed, but are still human at the end of the day. Now, of course, we all know this, or most of you know where this came from. This is Dune. This exactly describes the setup of the first book of Dune, released in 1965 by Frank Herbert. You might recognize the book cover, or personally my favorite incarnation, the 1984 Lynch film, Dune. Highly recommend you watch this, even if you've already seen the new ones. So that was in 1965. Frank Herbert's a sci-fi author. He's already thinking about, what does this artificial intelligence mean? What do these thinking machines mean for us as a species? So this is a quote from prominent thinker Hubert Dreyfus in a tract called Alchemy and Artificial Intelligence. No valid empirical or a priori arguments have been put forward to support the claim, the assumption, that, and therefore there is no reason to expect continuing progress in artificial intelligence. Now this sounds like something that people say today. This was also in 1965. So what most people don't know is that the conversations about the limits and the progression of artificial intelligence, we're retreading the same things that happened in the 60s, right? So even then, they were like, okay, if AI is going to be this big thing, you know, what's going to show up to finally enable it to change my life, right? To make all of my woes go away and solve all of my hard problems. But what they were looking for is their lisan al-gaib. So in Dune, if you haven't seen the movie or read the books, there's this concept called lisan al-gaib. It's basically the Messiah, right? So the people of Dune, they have been waiting for this Messiah to deliver them from their servitude on their home planet, and this voice from the outer world would come and lift them out of their subjugation and institute a new paradise on the planet. Now, of course, that's going to sound really familiar because that's how people talk about large language models and generative AI these days, right? It's this wonderful solution to all of the problems that you didn't know that you had. However, in security, we have yet to see any, in my assessment, material or significant leap forward in capability that wasn't already enabled by your basic machine learning algorithms or statistical algorithms, right? So the question is, where is our cybersecurity lisan al-gaib? The truth that I will postulate to you and try to prove is that AI can't solve security yet. Why? The main thing that limits this capacity is these three points here, right? First, human analysts and everything they do when they're looking at alerts, investigating incidents, trying to piece together attacker techniques, they are leveraging context subconsciously, right? Who here is either a security analyst or works with teams of security analysts? Quick show. Okay, a lot of you. One of the first things that your analyst does when they pick up a new system, a new alert, is they say, have I seen this before? But they're not explicitly asking themselves this question. Their brain is already computing, hey, does this look familiar? Wait a minute, I've seen that username. That's my system administrator, right? The brain is already making ties to past events implicitly that are never written down or stated anywhere, right? So humans are really good at this. But without that there, machines can't do the same thing. The second is that most of the tools that we currently work with in the industry do not allow us to record the expression of this sort of analyst knowledge in any real useful way. So the case in point I always make, and I always pick on Excel, but my parent company is Microsoft, so it's okay. Everyone dumps stuff in Excel, and they save it somewhere, offload it to the cloud or some off storage, right? I investigated it, here's my timeline, throw it in the bin. It's never looked at again. I can guarantee you that 95% of the work that most security analysts do on a day-to-day basis is basically completed, documented, hopefully, and then never referred to or looked at ever again unless there's an audit, right? SOC 2 audits, that's when you start pulling up all the old cases, right? Trying to make sure, okay, do we document things properly? So that's the limitation, right? Most of the security tools that our analysts use, they produce these sort of statically existent pieces of documentation that get filed away and they're never leveraged again. So what we lack here is this flow of information, right? The system gives information to the analyst gives information to the system. There's an exchange between your SOC analyst and your security and information systems, right? Your SIEM, your CTI, all of these things that we talk about. And that exchange is never recorded, right? So the point of this talk is that part of the reason why we haven't yet seen a huge leap forward in terms of generative AI and cybersecurity, or just new AI and cybersecurity, is because right now, very few companies are operating security operations centers that can benefit from the technology that these solutions offer. And the reason is, first, detection, and we'll go into detail obviously, but detection doesn't need to be a static operation, right? It's not a point-in-time observation, but rather a piece of a larger contextual triage that happens between a human and the systems. Second, the work that analysts do need to be fully modeled and recorded. And last but not least, the data has to continually move through the circuit, right? It cannot be left at rest. If you're ever producing security data, context investigations, classifications that are not continually being re-ingested, re-evaluated, and used to look at the next thing, then you are wasting the effort that went in to generate that information. If we solve these problems, this is the nice part, right? Even if AI never goes anywhere, right? From here on out, if you actually solve these problems, your analysts' lives will be tremendously improved, bar none, without any AI ever getting involved in the process in the future, right? Because as it turns out, and I hope you'll see, if you solve these problems, your analyst work will already be multiplied several times over in terms of its efficacy, its usefulness, and its ability to be shared collaboratively within and outside of the team. But once you get this, it turns out you actually get an additional ability to get more out of your AI solutions. So first and foremost, triage is all you need. So we use the word triage quite a bit in the industry, right? Sort of the standard incident response lifecycle. Triage, investigate, respond, right? Always start with triage. Now the problem is, classic problem in cybersecurity, we've kind of forgotten what the purpose and definition of triage was to begin with. So, of course, being the lame person that I am, here's a screenshot of a Merriam-Webster entry. At its core, right, top definition, It is the sorting and allocation of treatment according to a system of priorities designed to maximize the number of survivors, right? So, sounds a bit morbid, but if you've ever been a SOC analyst working a queue, and there are 100 items in the queue, and there are only 4 of you, it sure feels like you're working a military battle zone, right? You have to choose your next case really carefully to try and find the really bad stuff that's buried in all the noise. So it ends up being quite similar to normal triage in general. So triage at its heart is prioritization. It is not determining whether something is a true positive or a false positive. Let me repeat that because I see a lot of folks in this industry, especially data scientists, get this wrong. Triage is not classification, it is prioritization, right? It is telling your analyst, this is in fact the most important incident in the queue that you need to look at, not the other things right now, right? Those can wait. This one can't wait anymore. If, in the process of triage, and say, hey, this is probably a false positive, or hey, I know this is a true positive, that's awesome, and it's a great way to prioritize, but that's not the goal. So this will resonate for anyone who's ever worked in a security operations center. This is what the sort of day-to-day influx of work that we have to do looks like. At the top, you have detections. Detections are cheap, they're automated. You can, if any of you have detection engineering teams, right, you can write hundreds of custom detections that fire tens of thousands of times a day, and they all get lumped in the queue. And the next line is triage, right? What from that can we actually figure out we need to respond to? What of those things needs a full investigation? And what of those investigations do we need to then go fix? That is human-driven. In my experience over the last decade, you can reliably assume that triage should take somewhere between 5 to 30 minutes on the average analyst, on the average alert, and an investigation, if done correctly, should take between 1 and 4 hours for a single machine, single alert, if done correctly. Now, if you have X number of analysts, and to do their job properly, they have to take at least an hour or 2 per alert and investigation, you're quickly going to notice that the availability to handle the top dramatically drops. And we have to get very selective about what we take out of the queue. By the way, that's your SOC analyst. This entire process sits on their heads 24/7, 365, holidays too. So if you haven't thanked your SOC analyst recently, please make sure to thank them because the entire security of many organizations rests squarely on that tiny yellow triangle. So this leads me to the first point. To get effective AI in security, we need to know that its purpose is to direct the analyst's gaze to only the incidents that need it, right? AI is really good at doing large-scale data analysis really quickly. And it turns out if we provided a lot more context about the alerts that are sitting there, it's much more effective at determining what should be looked at, unusual things, high-risk things, right? Stuff that your analysts are already determining themselves. And it can say, you know what, I've seen this alert 2,500 times. Probably not important for you to look at that right now. So if we rewrite the script, it looks like this. Detections fire. When a detection fires, it goes into a pipeline where it will get additional context. What does that mean? It means that the entities, the hosts, the users, the IPs, the domains, the hashes will all be extracted. You will go enrich them with your beautiful SIM queries and sources and all those wonderful things that we pay for. And then you can apply logic that will prioritize and potentially fire off any pre-response activities, right? If it's, hey, this is really bad, all right, let's go contain the system right now. Or hey, I think this user got phished. Well, let's go ahead and reset that user's session tokens. So if they got stolen, they're no longer valid, right? It's not gonna hurt the user any, but it will buy us some time. So you build all of this on top of proper data pipelines, cooking your data properly, right? Data layers, machine learning and AI. And it turns out it's already really good at doing this. And the reason why is because the rest of the engineering world, as I found out when I became a real engineer, has been doing this for a decade, right? Real machine learning scientists have been doing this for a very long time. They process way more data than we could possibly imagine, extracting all kinds of wacky insights out of it. And so now, when you look at the investigation and response, the burden is much lower on the individual analyst because the work, that really big drop from detection down to triage, you're starting to share the load with a system that can scale much further than a human can. And this leads us to an important realization that I made, is that we need to change the way that we think about detections. And this will open up the ability for AI to do much more interesting things. So if we change our mind from the situation we have today, where we fire a detection, it goes into a queue, and someone pulls that alert out of the queue and investigates it, and instead said, wait a minute, fire detection, you have 10 minutes, right, 10 minutes to do whatever you want to that detection. Go get additional enrichment. Go look similar incidents in the past, right? Go find anything that looks similar to this, and let's pin it in there, and we'll let the analyst look at it, right? Go do this wonderful contextual enrichment stuff, and then, and only then, make a determination, hey, is this really a high severity, right? This is really similar to one I graded before. I graded that one at a low. This is fired 8 times. They've all been graded as false positives. Probably not worth looking at a high priority. So maybe we lower the severity, or alternatively, maybe we raise it. Hey, this alert's been a false positive, but that user's a domain admin. Maybe I should go look at that one for sure, right? Because probably not a false positive for all users all the time. So if we give room for our automation, AI, whatever you want, right? Doesn't have to be AI, it could be anything. And then we add the context to the incidents, then when we feed it into the AI system or to the analyst, it already has the context with it, right? Now the AI knows this alert fired, this is the system, this is who owns it, this is their job, this is their privileges, this are their groups, right? Now the AI has this wonderfully full package that no human analyst will ever assemble. Because if you tried to make me add that level of context to every incident I investigate, I would immediately quit, right? Because I'm not writing a dissertation for every medium grade alert that fires in my system. But automations and AI do a really good job at summarizing and adding that stuff in for you, right? You do a little bit of the legwork, automate all the busy work, and then suddenly your systems have a lot more details related to the alert than just the context in the alert. So after that, triage, right, comes investigation. So investigating things sucks, right? I think everybody knows it. Sometimes you get interesting investigations, but for the most part, it's tedious drudgery. So on the day-to-day, data sources are disjointed. I have to have 12 tabs open all day, every day. I get to bounce around all my different security solutions. Hey, let me look up this IP. Oh, I need to go over here to look at this domain. I gotta go to to look up this hash, right? We're doing all these things manually in a bunch of different places. And possibly the worst offense of all is that most security tools in the industry today, even from large vendors, are not designed for collaboration, right? I can't be working an incident, be like, I'm kind of stuck here. I got a little bit of it. This is bad. Here, let me pass off my investigation exactly as I have done it today to another person. They can jump right in where I left off, see everything that I've marked as good, bad, benign, whatever, suspicious, and can immediately pick up and go, right? Almost no tools today offer that kind of collaboration experience. The worst part of this is that almost all the work we do gets tossed in the garbage at the end of the day, right? The average analyst looks at anywhere between 8 to 10 alerts a day. All the work that they do usually gets summarized in some sort of closure note, right? This was bad because this domain is associated with blah, right? Closed. Never think about it ever again, right? So all the work that they did to determine this, probably not making it in your ticket, right? Definitely not making it in the comments of that incident, unless you're a really, really good shop. But it goes somewhere, probably on the user's personal notepad or something like that they use to keep track as they go, and then we forget about it. So we lose a lot by doing this. The context, right? So all the additional stuff that investigator found, it's probably really important for future investigators to know, hey, this is how I looked at it. This is where I got this information from. Here's the data sources I used. And in most cases, you're also not even getting tagged events, right? Like, here's the specific events in my SIM or my security tool that are related to this attack, so that I can then hand that off to, say, Intel, detection engineering, you name it, right? Give them the specific evidence related to the incident so that they can do their work on top of it. And then last but not least, the connection between our data sets. And this is something I think a lot of us take for granted, right? So when you're investigating, say, like an endpoint incident, you say, oh, they downloaded this malware, they launched it. This malware then launched another process that then made a network connection. Now, we're crossing the boundaries of several distinct data sources, knowing the connections between them. Oh, I know this is the child because the parent PID, the child PID is that, and then the detection came from this PID, and I know they're related. So we know this all in our minds because we're constructing the story as we're investigating, but none of that gets written down, and none of those connections exist beyond that single act of investigating this incident in almost every case. So now, the proposal I have is, well, let's change the way that we do this, right? So let's pretend for a moment that we do language, right? So Austin picks up an alert 9381. He finds a suspicious event. There was a process that spawned. Here's the process ID and the process name. I then go and I look, hey, what's the prevalence of this particular process? It's on the name. Then I say, okay, well, what's the process based on the MD5, right? And I start investigating and adding more context and figuring out how bad is this unusual, right? So let's look at this visually. So this is just example data from KC7 Cyber, who are a great nonprofit group that does a lot of investigation, threat intel work. So highly recommend you check them out. But we start from an alert. We go to the endpoint. We say, hey, here's the alert. The alert was talking about a file. Here's the file. Okay, well, what's the next thing we do? We say, all right, well, how prevalent is the file? I go look at that. I say, hey, show me any events related to this MD5. And I'm like, holy cow, there's a lot of bad events related to this MD5. And I am only 2 levels deep, right? Now I can pivot on everything else you see in red at the bottom. And when you do this, it starts to look like this, a graph, right? We are creating, subconsciously, a tree of connecting stories between all of our distinct data sources that tell us, hey, this is bad, this is good, this is connected to this file name is connected to this, right? We are doing these things consciously, and we need to start modeling them more explicitly. So AI will help us, if we do it correctly, render the investigation lifecycle end to end, right? By changing analysts' behaviors, what we do every day, into a learnable language, right? Every pivot is a connection. Every enrichment is context. And if we start building the story more completely by looking at the analyst's actions as an expression of a particular language, right, the security language, then it turns out large language models can actually apply their skill sets much more aptly because they need things to be expressed as languages, right? And we say language, what it really means is a series of tokens in particular orders according to certain grammars, right? It doesn't even need to be words, it can be pictures, whatever. But it needs to be expressed in a way that the system can interpret, collate, connect it internally in the large language model, and then actually generate something of use, right? Not hallucinate, things like that. Also, if you do this, it turns out you're basically constructing what in the industry is known as sort of a knowledge graph, where you can then get really crazy and start doing things like graph RAG integrations into your LLMs, which means that now your LLM can query all the graph of all this connective tissue between your data sources and your previous incidents and leverage that in analyzing new incidents, right? Which of course brings us to the last piece. So this process is generating a ton of data, right? If we do this correctly, if we model things correctly, if we enrich things correctly, we're generating more data intentionally. So how do we steer this, right? So you can't just give someone all this data and expect it to magically pop out the end looking like this beautiful summarized investigation with all these wonderful suggestions and basically like, hey, do you want me to go take care of this for you? That's not going to happen. But we can build our way slowly towards this solution. And the way that we do that is we start thinking about security as a pipeline, right? Always a pipeline, end to end. And we abandon critically the idea that LLMs solve all problems, right? LLMs are great. They can do things that other models can't. But anyone who's been working in this industry long enough knows that there are enough really good machine learning technique model styles that already work really well solving particular problems, that you can build a combination of these systems interacting with each other and get much better results. So if we look at this from a pipeline view, detection is the starting point, right? And this is assuming you write your own detections as well, which some of you don't, but most of you should be if you're not. So you write your detections, you deploy them via CI/CD, the detection fires, and that detection goes into your enrichment and triage pipeline that we talked about in the first section. That's going to do the contextual analysis, extract the entities, enrich them, overlay your prioritization logic on top of it, right? So now we have, ideally at this stage, all of your alerts prioritized in order of need so that your analysts know what meets the bar, what doesn't meet the bar, right? And they focus their attention only on the things that meet the bar. Go to the investigation part, right? Analyst takes the highest priority item off, they dive into the timeline, they start tagging and commenting events. They are getting into the data as deep as you possibly can. Every process, every file, every network connection, every domain, IP address, MD5 hash, whatever, right? They are manually tagging this because this is what really good investigation looks like. It is thorough, it is complete, it is going to analyze every angle of this. And then we feed it back into the system, right? We're taking the work that they did, we're saving it, and we're making sure that anytime a new alert fires, we're similar alert or different alert, right? All of the work that went into analyzing this historical incident is now accessible, right? The AI can query it on demand and say, hey, what did this investigation look like? Like when Austin looked at this a year ago, what did it look like? What did he find? How are these things connected, right? What were the entities involved? Okay, now that I have the context, I can look at the current alert and say, maybe this isn't that similar. Maybe someone should look at it because this is looking very different from the last one that we looked at. Or better yet, say this looks identical to the last one. Let's pre-plan the investigation, pre-plan the triage, right? Pre-plan the containment, and allow the analyst to execute it without a bunch of additional effort. So when you do this, you start to build a system that I call the sort of AI is the institutional memory, right? So the idea is that AI becomes the institutional memory of your security organization because it becomes the thing that you offload the mental burden of remembering all the incidents you've ever investigated, how they were investigated, and what you found. So these three things. One, where have I seen this before? Have I seen this before, right? Two, what can help me investigate this further, right? So if we find an alert and we know the pivots that go along with that alert from the jump, then I can pre-process that, get that ready for the analyst, put that in front of them, ready to go, and I can cut the investigation time down, cut the guesswork down, and make it so that an entry-level analyst or a junior analyst can benefit from all the work that their more senior colleagues are doing because all of that knowledge that they have, they're expressing it in a tool that can then render it useful for other people. And then last but not least, and this goes mostly ignored, as far as I've seen, right? There's not a lot of talks on like how to QA your investigations properly, right? So it turns out it's really hard, very time consuming, and as little as possible because it basically means you have to redo the investigation. But not if you build an AI system like this. Because now you can say, hey, here's my investigation. Here's all the bits and the things I tagged, and here's the alert and what was contained in it. And it can go through its file and be like, all right, I haven't seen this before. This looks new. All right, but this is similar to this, and these pivots were useful. Okay, these pivots were done. Okay, I see, all right, they've correctly bounded the time based on what I can see from previous work and other enrichments that I've done. Yeah, this looks pretty good. Or if they look at it and they say, hey, in previous network alerts, they looked at this pivot going for like domain name resolution history. I noticed you didn't do that here. Maybe you want to take a look at that and come back to this, resubmit this again, and we'll double check it, right? Now, a normal human can quickly do that, quickly, 5 to 10 to 15 minutes for a small alert. But you can't do that for every alert. But this system can, right? If you know what to expect and you know what a thorough investigation looks like for a certain class of alerts, then you can enforce the standard of quality automatically and in a way that hopefully helps your analysts improve, right? Because it's like a little coach. It's like, hey, I think you might have skipped a step here. Can you just double check? And maybe the response is, no, this is good, right? This is totally fine. And then the system's like, oh, cool, thank you for letting me know. I'm gonna remember this next time we run into this kind of alert, and I won't have to bother you about it again. So the model intentionally looks a little bit like this, right? So there's a constant interaction between you and whatever AI agent thing that you're constructing, right? The particulars don't matter. It could be one, it could be a bunch, right? It could be monolith, microservices, doesn't matter. The analyst is always getting and receiving feedback from the AI, and the analyst is working, contextualizing information, rendering it into a language, right, the investigation language, and then submitting it back to the AI so that it can get something back in return, whether it's investigation suggestions, suggestions on containment, similar incidents that you should look at as part of your investigation, right? It's a constant flow of information back and forth between the human analyst and the AI, which leads us to the last principle. So, at the end of the day, in my opinion, what great AI and security looks like is externalization of the memory of all of your analysts, right? It is to become the oracle of all the experience of your security analysts over the years. It will remember quickly and seamlessly every incident, every event, everything tagged, every IP domain, right? It will remember it immediately upon needing it, and it will help contextualize new things, right? Connect past events to current events without skipping a beat, right? So, at the end of the day, if we're doing this correctly, right, which so far I don't think we really have, AI needs to be a spotlight, not a funnel, right? It needs to draw attention and focus towards particular parts of incidents, investigations, right, parts of your network, not filter them out, right? If you have AI acting as a filter at the very top, you are going to miss something and it is going to bite you, right? Don't let it become the deliberate sort of like, no, you can never look at this again, I'm gonna throw it away for you, don't worry about it, right? It needs to be more of a prioritization, not a filter. Second is it's gonna help us create a language that can then be learned and modeled continuously between the AI agent and the analyst, right? Because everything we do is a language. We just don't have tools that can express it as explicitly as it needs to be expressed for the current AI systems to do really well. And if you haven't seen the most recent model release from OpenAI, I think this really proves the rule, right? So OpenAI went and released the new model that focuses a lot on hard scientific technological problems, right? So this new model O1 is really solving math problems, physics problems, chemistry problems. And the reason it is because they intentionally created this sort of recursive thought chain that it goes down as it questions and breaks down information iteratively with itself, right? So it changes from the previous models. And so you go from something that can't tell you how many R's are in the word strawberry into something that can solve incredibly difficult math equations that almost no one in this room could probably solve given a week to solve them, by making a small adjustment in how you model the thing, the science, the math, how you model it as language and how you get the structure of the AI to interrogate itself, right? So that's where we're trying to move from a security perspective. And then last but not least, of course, AI needs to be the memory of the SOC. So at the end of the day, this needs to be, everyone has that tier 3, tier 4 analyst. They've been there for years. They know all the ins and outs. They know where the bodies are buried. You give them an alert and they'll be like, yeah, I saw that 2.5 years ago. It was a Tuesday at 3 o'clock. It was a false positive. Don't even worry about looking at it, right? So now you take that, right? Everybody has that person that they go to. You take that and you create a system that anyone can interrogate at all time, and you don't need to bother, Cheryl or Steve or whoever your version of that is, whenever you can't make a decision on something, right? Now you have the ability to get that context given to you in a way that you can use it. So, assuming we do this correctly, even if AI doesn't turn out to be this wonderful panacea, right, this beautiful solution to all the problems that we have, these systems, you can build them today. I know this because I built a system very similar to this for LinkedIn. And it turns out that when you approach it step by step, it's actually not that hard to put these components together. You just have to change the way that you think about the problem. So one of the things that we did to try to make this more accessible to folks is you saw screenshots of the investigation graph. That's from an open source tool that was released by Microsoft and is supported by me and one of the members on my team called Tim. It's an investigation platform that is precisely designed to transform the normal of just tagging and building timelines into a more context-rich, layered sort of graph constructing activity that you can then take those signals, right? The signal of how someone investigates something and plug it into your system, right? I don't know what system you guys have or what system you want. It really doesn't matter. Once you get that information and you connect it to the right interface, you're going to get a lot more value out of the work that your analysts do. And most importantly, the analysts are going to get a lot more value out of the work they do, right? So I kind of cynically put this in the title of the talk. This is an analyst-first perspective. Because at the end of the day, if you do this correctly, your analysts will thank you for it because it will make their lives so much easier. Because what a lot of people forget is that it is extremely nerve-wracking just making a decision like, I'm not going to look at this alert, because you're constantly thinking, what if this alert is SolarWinds, right? We all know from all the literature that comes out about big incidents, there's almost always an alert that got mishandled or not looked at, right, at some point in time, and no one wants to be the analyst that holds the bag on that one. So we have to build systems that support our analysts and can relieve some of the pressure off their shoulders and be like, listen, even if you goof up, right, you're gonna make a mistake. Don't worry, we've got a safety net here, right? It's gonna find things that we miss regularly, no harm, no foul. That's part of the system. We don't want the human to be the single point of failure. So if you do this, if you build this, your analysts will be very grateful. And if you figure out a way to integrate it into your AI, your preferred AI platform, right? There's so many different AI models. Then, and maybe only then, your analysts will start to see AI as this. Thank you. All right.
I have a question. Maybe on purpose, you didn't mention any metrics or quantifiable metrics, so it's great analysts to feel great and thank us, of course. But are there any metrics like MTTR, alert to fix, or some other new metric?
Oh, yeah.
That will reflect, hey, here's some ways that we're better.
That is a really good question. So it turns out most of the core metrics we track are directly influenced by systems like these. So for example, if you do time to triage, time to close, right, these things, this system dramatically improves that, right? Time to triage especially because it handles all of the busy work of properly triaging incidents and dramatically drops that. So we're talking like 30 minutes down to like a couple minutes. And then time to investigate also drops too, because it turns out most of the context that you're pulling from the enrichment pipeline is pivotal to solving the investigation faster. So in our experience, what we've noticed is it not only helps the metrics in an obvious way, right? It looks at more incidents faster, gets more data collated and collected faster, but it makes the analyst experience of investigating things much better, right? So when we went to, you saw the grid view of the alerts, right? When we moved to that system for doing our investigations, investigation time dropped dramatically because pivots are built into the tool. You never have to think of how to write a query to get from data A to data B because it's already been written for you and you can reference it at any time, even if you don't know the underlying language that it uses to give you the data. So it significantly drops almost any SOC metric that you're looking at because it cuts down on the guesswork, the delay, the waiting that often plagues like the analysis phase of things. But the big thing for me was it increased the scope of things I could analyze, right? So, humans can only look at 8 to 10 alerts a day without losing a ton of quality in the work they do. So if a system can look at 10,000 alerts a day without skipping a beat, then I can relax my restrictions on fidelity for the alerts that I write, and I can start finding things that I would never have been able to find because I can go deep into the noise and start elevating things out without putting that burden on a human. So metrics, definitely better, but also the metrics that people aren't thinking about, like what is the scope of things I can even review, how much incidents can I look at a day, that is going to dramatically improve as well.
Hey there. So I have this question. So with a lot of things happening over AI, how do you suggest AI would help us get rid of false negatives?
Yeah, so it actually ties a little bit into the answer. So in my opinion, right, the reason that we deal with false negatives as often as we do is because the primary authors of alerts are the product owners, right, the vendors. They have to enforce, understandably, a meaningful level of filterization based on confidence, right? They can't give you an alert that's like, maybe it's true 5% of the time, because if that alert fires 100 times, you're gonna go right back to them and say, hey, you're showing me this garbage. Why are you showing me all this garbage all the time, right? So they have to operate by a set of rules that restrict them from being able to maybe write some of the detections that in your particular environment are actually super high fidelity because it's the detection you could write is tailored to the environment. So one of the things that AI can do is both open up a space for us to write lower fidelity detections, right? And in a world where, well, maybe I write this and maybe I say it's a low severity, but then I have an AI go in and look at it and be like, ooh, actually, no, this isn't low anymore because these other things happened around it. Let's go ahead and raise that up, right? That system doesn't exist today in most products. So we ended up building it, but I'm hoping that most product vendors follow suit, and when they integrate AI into their systems, it'll create a more dynamic space to like kind of play around with detection logic in a way that you're not intentionally leaving something off the board because it's too noisy. Because like noise is only a factor for humans, right? If an alert fires 8,000 times a day, but your system can review all of those in fractions of a second, who cares, right?
So it sounds like this took a little bit of ramp up time. So you have to change your processes so that you can start building the knowledge so that the AI can actually be assisting you. How long did it take for you to really get to a place where it started being effective?
Yeah, so all in all, probably about 9 months to make the full transition. And to be honest, we're not done, right? Like AI is improving iteratively, right? In terms of its form, function, different options that you have, new models, right? So, every time something changes, we go back, we test, right? We can do regression tests, be like, oh, if we had this model, would it change the outcome on these incidents, right? So you end up creating a process that is going to iteratively improve itself, hopefully over time. But the lead up time for engineering something like this is not insignificant, right? I'm not I haven't been a professional engineer for very long. So I had to learn a lot to build these things. But I'm pretty confident that anybody that has a team with some good engineering chops can essentially build the same thing. I'm also hoping at some point next year to open source our enrichment and triage pipeline, just so that we can remove that as a component that you now have to build.
If the analyst goes to the business and then say, hey, AI is my savior, can you implement this so that it'll make my life easier? But do you think that the business will agree for that?
Sorry, what was the last part?
Do you think that the business will agree for that? Is there any other business?
Well, the business will likely fund it. Oh man, that is not a security question, unfortunately. That is like a business priorities question. So if you're not in an organization that values security or that feels the pressure from security, they're probably not gonna fund any suggestion that gets made, to be totally honest. But what I found working with my leadership and talking with folks across the industry, there is a ton of focus on, right? Scaling more with less human resources. So when you say, hey, I know you're not going to give us headcount, right? Because like, oh, headcount, no one gets headcount anymore. How about you give us this amount of budget to build this? And then you can say, you know, all right, much less headcount, but like this system's going to make everyone else's lives better. Because the alternative is you lose the headcount, you never get it back, but everyone has to keep doing the same scale job with less time. So it really depends on the organization.